Have you ever wondered how two tiny particles can seem to share a secret, even when they are far apart? This strange idea is called quantum entanglement. It is one of the most surprising discoveries in modern science. Two particles can be linked in a special quantum way so that their properties match up better than ordinary objects ever could. If scientists measure one particle, they can predict the result for the other, even if it is very far away. At first, this sounded impossible. In 1935, Albert Einstein, Boris Podolsky, and Nathan Rosen argued that physics should be local. That means one object should not instantly affect another far away. Einstein did not like the idea that a particle might have no definite properties until someone measured it. He called the effect spooky action at a distance. But nature kept it secret for a while. In 1964, John Bell found a smart way to test the question. He showed that if the world followed Einstein's local idea, then the results of certain experiments would have to stay within strict limits. If the results broke those limits, then something stranger was going on. That is exactly what later experiments found. From the 1970s onward, scientists such as John Clauser, Alain Aspect, and Anton Zeilinger built careful tests with pairs of entangled particles. They separated the particles and measured them in different ways. Over and over, the results showed the same surprising pattern: the particles were connected more strongly than local common sense allowed. What does this mean? It does not mean particles send secret messages faster than light. It means quantum particles are not like tiny marbles carrying hidden labels in their pockets. Before measurement, some properties are not settled in the usual way. The measurement itself helps choose the outcome, and the two entangled particles still match in a deep, quantum pattern. This is one reason quantum physics feels so different from everyday life. A ball on a table is easy to picture. A quantum particle is not. It can act like a tiny wave of possibilities until a measurement is made. In 2022, Clauser, Aspect, and Zeilinger won the Nobel Prize in Physics for experiments that helped show how nature really works. Einstein was brilliant, but in this case, the universe turned out to be even stranger than he wanted to believe. The lesson is simple and amazing: the world is not always built from fixed pieces with fixed properties. Sometimes, nature keeps its choices hidden until the very moment we look.